Dear students, I welcome you for the digital learning class on P integrals. So these P integrals play very important role while solving the examples using comparison tests. The first theorem in this is integral from 1 to infinity of dx by x raised to p converges if p greater than 1 and diverges if p less than or equal to 1. Here we are dealing with improper integrals. Here infinity is the point of discontinuity. Now we have to show that this improper integral converges if p is greater than 1 and diverges if p less than or equal to 1. Proof. Let us consider the first case, that is when p greater than 1 and b is given as greater than or equal to 1. It lies between 1 to infinity. Now infinity is the point of discontinuity here. So limit as b tends to infinity of integral from 1 to b of x raised to minus p dx. It is nothing but integral from 1 to infinity of dx by x raised to p. This limit is equal to limit as p tends to infinity of integral of x raised to minus p with respect to x is, we know that formula. So according to that, x raised to minus p plus 1 divided by minus p plus 1 limits from 1 to b. So this is limit as b tends to infinity of, and now substituting the limits we get b raised to 1 minus p divided by 1 minus p minus 1 by 1 minus p. This is the value after substituting the limits. Equals limit as b tends to infinity of given value for p is greater than 1. If p is greater than 1, then this becomes negative value. Then b raised to this, it comes to the denominator. 1 divided by b raised to p minus 1 into 1 minus p minus 1 by 1 minus p. So after taking the limit as b approaches infinity, So this term, this denominator tends to infinity means this first term tends to 0. So after simplification, we get 1 by p minus 1, which is finite value. So what is this? This integral. It is finite means the given integral is convergent. And next case, this is the case when p is equal to 1. When p takes the value 1, then integral from 1 to b of x raised to minus p dx, it takes the value, it becomes integral from 1 to b of 1 by x dx. After integrating, we get ln of x. Limits from 1 to b, it is nothing but ln b minus ln 1 equals ln b, because ln 1 becomes 0. Okay. Now what we want is integral from 1 to infinity of x raised to minus p dx. It is nothing but limit as b tends to infinity of integral from 1 to b of, here p is 1, so it takes the value 1 by x dx. This integral is nothing but this limit, and it is nothing but limit as b tends to infinity of ln b. As b tends to infinity, this value also tends to infinity. Therefore, this integral tends towards infinity. It becomes infinity. It is not finite value. So that integral diverges. So next case, when p is less than 1. When p is less than 1, integral from 1 to b of x raised to minus p dx, it becomes, its integral is x raised to minus p plus 1 divided by minus p plus 1. Limits from 1 to infinity equals, after substituting the limits, it is 1 to b. After substituting b raised to 1 minus p by 1 minus p, according to the rule minus. If we substitute 1 here, it will be 1 by 1 minus p. And what we want, that is integral from 1 to infinity of x raised to minus p dx. It is nothing but limit as b tends to infinity of integral from 1 to b of x raised to minus p dx, it is nothing but limit as b approaches infinity of b by 1 minus p minus 1 by 1 minus p. Here b raised to 1 minus p. P is less than 1. P is less than 1 means the as b tends to infinity, infinity raised to means it is finite quantity, it becomes infinite quantity, it is finite. So after taking the limit, it tends to infinity as b tends to infinity. Therefore, the given integrand, that is 1 by x raised to p, if we integrate from 1 to infinity with respect to x, it diverges when p is less than 1. So, it's a behavior of this improper integral is it converges when p is greater than 1 and it diverges when p less than or equal to 1. So, very simple theorem. Just here applied the definition of convergence and divergence of the improper integral. Thank you.